smarter about our homes and houses, right? Because we can't build really leaky homes anymore and just throw in a larger boiler and call it good. No, we have a problem with carbon dioxide, and we need to deal with it in order to combat climate change.
Welcome to the Fine Homebuilding Pro Talk Podcast, a regular discussion with building industry professionals. This is Senior Editor Patrick McComb. Today I'm joined by former solar installer George Hart.
Hey there.
You can find the Fine Homebuilding Pro Talk Podcast and the original Fine Homebuilding Podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there too. George, thanks a million for being on the show, buddy.
Patrick, I'm a huge fan of the show, and I'm so excited to be able to get to talk to your listeners.
Well, we became acquainted because you wrote into the regular Fine Homebuilding podcast with some great information about whole house batteries. You told us that there were more than just the offerings from Generac and Tesla that we were talking about. You also told me on the phone that you have a communication degree and an interest in solar. So you started working for a mom and pop solar company 24 hours after an inquiry.
Yep. That is a 100% true story. So two things there. So Generac and Tesla, I think, are some of the largest brands that, a regular person would recognize and be familiar with. But I think it's also important to know that like everything, there are a lot of OEMs, original equipment manufacturers, and battery makers and inverters and companies that have been doing this stuff for quite a long time, basically since the off-grid movement started in the US, in the late 70s, early 80s.
These are folks like our longtime editor, Martin Holliday, who have lived off the grid since that time. And
Exactly. There's this vein in sort of the renewable power sector that, is basically grounded in the off-grid movement. It's people that are living way back in the woods where in order to get, a utility service, it was, tens of thousands, hundreds of thousands of dollars. And there's also a movement more on the West Coast where it was people doing some maybe some illicit hydroponic activities.
Right. They needed power that was more autonomous, right?
Yes.
You couldn't buy it from the grid, right? It had to be self-reliant, right?
Exactly. So, so I'd like to think that the solar industry has its roots here in America and, deeply, deeply strange, which I really appreciate. But that was a quick tangent. But yes, so I got my start in the solar industry, and it took me about 16 hours to get a job.
I got questions. You went to school for a communication program, but then you got out of school and you decided you wanted to do something else, right?
Yep. So I graduated school with a communication bachelor's because it allowed me to basically make my own college experience. And when I got out of college, I was heavily involved in the performing arts. So I was working backstage at my theater carpentry shop. I was doing lighting and sound for the various shows on campus. I was mixing bands with the Student Technical Association. So when I graduated school, I thought to myself, I'm gonna live and breathe the rock and roll business. That's what I'm gonna do. That's the career for me. And so I was living in Philadelphia at the time, and I wanted to transition industries. I was tired of working every night and weekend, not really.
So at this point, you were setting up for live performances, you told me. So you were actually hoisting speakers up in the air and then connecting them with cables to some soundboard. And
Yep. And then running a show or doing that with, lighting rigs or, even just showing up at the end of a job, at, parties over at like midnight. You show up at 11, you get home by, maybe 3 or 4 in the morning. And, it was fun for a while, but I wanted something more with more consistent hours, with better benefits, health insurance and dental and things like that. And so
So you immediately thought of residential construction, right?
exactly. I was 23 at the time, maybe I was, maybe I didn't know everything, but yeah, so I reached out to a residential solar contractor in Northern Philadelphia. And I said, hey, I'm interested in the solar field. Do you guys have any like internships that you do or anything? Like, I'd love to be able to come and help out. And then I think it was within like 2 or 3 hours, I got an email from the owner, and he's like, I'd love to have you come down for an interview. And so I went down and I interviewed.
The same day.
That it was the next day, because I think it was 4 p.m. by the time they got back to me. And then, so I went and had the interview, and he said, all right, you've got the job. And I never really understood what job that I got. So he's like, show up next week and be ready to finish drywall. And I was like, okay. And so that next week I was on a roof, picking up solar panels and learning how to install.
What about the drywall?
That was for a unrelated project that got finished at a much later date.
Okay.
He was the owner of this company, which is still in business today. Kind of a wild, eccentric guy. So there was always something going on.
Did you like the work? I'm sure it was physically demanding. That stuff doesn't get up on the roof by itself.
Mm-hmm. Yeah, I did actually enjoy the work. It was, I was used to doing, some, working with cables, working with, technology. But it was a lot. It was different. It took a while to feel really comfortable on a roof, and getting familiar with how to, manipulate all your PPE to, work effectively on the roof. But after a while, you get into this really, kind of rhythm. And especially with, once you get on a good roof crew, like, the guys that I worked with were really good. Once you get into a rhythm, like it's really a nice feeling to be able to, set up a bunch of, set in a bunch of flashing, put up a bunch of rails, snap your chalk lines, and away you go. So like I did really, really enjoy, that sort of economy of movement,
I've observed that crews that work well together don't even have to talk. Everyone knows their job, and stuff just gets done without a lot of communication. They might be talking, but it's not about the work, because that's happens.
And you eventually, it just sort of becomes second nature, and you learn how to read the plans that that are being generated by your internal designer, and then you sort of get to learn their quirks, and then it's really, you really get into sort of this rhythm, this pattern, and where things can happen really efficiently. And who doesn't like being a part of a really
smooth
efficient
team, right?
Team. It's really great.
On the other hand, though, I'm sure it is blazingly hot, right, in the summertime, and you're crawling through attic crawl spaces, pulling wires and basements and probably other horrible places. What's that part like?
Oh, it's not all glamorous, Patrick. Let me tell you. You're dealing with hot asphalt shingled roofs, mostly in the northern U.S. You're you're doing site investigations where you're in someone's unvented hot roof, and you're crawling around on trusses trying to make sure that you don't fall through the ceiling, like, sweat pouring off you. Sometimes you have to deal with, loose fiberglass insulation, which is just
horrible.
Yeah. So, it's not all glamorous.
Yeah. you've had two or three other jobs between the position we've been talking about and what your work is now. Can you talk about the other things you've done and what your current position is?
Yeah, my career path.
Because you've had what I would describe as a meteoric career path.
Yeah, I'd agree. So, so I got my start in the summer of 2015. That was when I first started. And then when I was with that company and their designer left, probably about August, September of that summer, to move to Colorado to join a larger solar company. And so I was the only one on the roof crew that had a college degree in anything, let alone communication. And so I was approached and they said, "Hey, would you like to learn how to, do the design?" And I was like, "Yeah, I could learn how to do that." And so I jumped in, and I think I had about 3 days of overlap between the designer that was leaving and, me picking it up. And I remember asking him, like, "Okay, so how do I do this?" And if I remember his look at the time, it was, I'm glad that I am leaving. And so, so I started designing with that solar company, making mistakes along the way, and working with our electrical staff, and learning the craft of how to design these systems, and not just install them. Then, while I was still at that company, I got an industry certification called NABCEP. So NABCEP, the North American Board of Certified Energy Professionals, is a credentialing organization. I think they're a not-for-profit.
Is it strictly solar, or is it other electric utility work?
So it is solar. It's solar PV, solar thermal. So a hot water system. I think they also do a wind program, and there might be one other, but it's funded by the sort of like industry trade associations. So I'm pretty sure that the solar industry has its own trade organization, and one of the things they do is they fund this credentialing organization, NABCEP. And so, because renewable energy is growing so quickly, I mean, just tons of growth. There needed to be a way to figure out, like, okay, this person knows what a solar panel is. They know how to deal with it. They know what a roof setback is. They know what PV cable is. They know what this stuff is. So I got my credential through them. And then I moved back to Western New York, which is where I'm, born and raised in Rochester, New York, and lots of friends in Buffalo. So I moved back up here to Buffalo and got a job with a larger residential company, designed for them, worked with their installation crews, did a lot more site investigations, did a lot of, troubleshooting, got to work on a couple of larger commercial systems, some really, funky electrical setups. Then I got a job in Minneapolis. So I moved to Minneapolis for a renewable engineering company. So we were doing electrical designs for stuff that's, 1 megawatt plus. So things that are, 20 plus acres, all the way up to, I think my largest project was something like 200 megawatts, which is
that sounds like utility scale. Am I right?
Yeah.
Yeah.
Yep. So, it was a huge culture shock going from, a residential based company where I'm, jobs take 3 days, to working on, systems that take, 18 months to install, not, and then there's a whole design legwork
and permitting, and I'm sure all kinds of stuff.
Permitting and, utility meetings and public meetings and things like that. And so I did the engineering side, and then I got the opportunity to come back to Buffalo to work remotely for a large utility scale contractor. So that's what I currently do now. And so I'm working with a contractor that is basically in charge of installing these large solar projects. And what I do is I review engineering drawings and
Make them work.
Not necessarily make them work, answer questions, and help clarify things, and translate.
I find it interesting. It's just an observation that someone with a communication degree but lots of practical experience can be interpreting engineering drawings for a contractor that has to build this stuff.
Oh yeah, and I mean like to your audience and to the listeners out there. I mean, I'm by no means perfect. I do not know everything about these projects, and there are certain areas where I just I'm just like a regular guy that knows how things get drawn and put together. But yeah, I mean, and I think a part of that speaks to the quality of the mentors and my colleagues that I've had the opportunity to work with. It's been a lot of like osmosis and getting in there and making mistakes and learning by doing, and being able to take feedback. So I mean, I've been really fortunate to have really, really great mentors and colleagues and friends.
We were talking ahead of recording here, and you said that the growth potential for people in the solar business is limitless if you have some ambition and some smarts, right?
I mean, what was it? I think the latest job reports came out, and job projections really. So installed capacity, the amount of solar that we have in the US, I think is about 16 gigawatts across the whole country. By 2030, that number is projected to double. And then I think 2030 to 2045, it's going to double again.
And we have to keep in mind that it took decades, right, to get where we are now.
Exactly. Like 1970, I think 77 is when the first PV panel is patented and invented, and yeah, from then to now, 16 gigawatts, and in 10 years we have to double that.
I want to ask you. I'm sorry to interrupt. Go ahead.
No, I was just going to say, so it's a field that needs a lot of talent. We need a ton of people to come in and that want to do this work.
So how does one train to be a PV designer or installer or manufacturer, I guess? I mean, these folks.
Man, that's a good question. Really, it depends on, where you are in your career path. If you're someone just coming out of school, or if you're someone, graduating high school or coming through a community college, I think it's a lot easier to get a job with a residential installer and working with them, getting your hands on that experience. But, if you're more of like a mid-career professional, it's all about kind of, how you're going to adapt your existing skills to, what the industry needs. Like if you're a project manager for an HVAC installer, we need project managers too. Or if you're an engineer and you want to come in, you just got out of engineering school, like it's really easy to get like a co-op internship and working through that pipeline. But yeah, I mean, like there's like any business. I mean, we need all sorts of people. We need electricians. So working with, how people become electricians. So it's going to be the same sort
the
of
union
thing.
or trade school,
Either through the union or trade school, or working directly with a master electrician. It's going to be working through that, but it's all other flavors of the trade.
I presume if you wanted to be an installer, contacting a local PV company would probably get you at least to talk to, right? I mean, there's such a need of people to do this work.
Oh yeah, 100%. Just reaching out to, who's doing that work in your area, and, if they're not needing someone, normally normally people are going to pay it forward and say, hey, we're not at that point yet, but there's this other company out there. Yeah.
I'm going to ask you about residential systems for a little bit, because a lot of folks who listen to this show, I'm sure, are interested. But then we're going to talk a little bit more about more global questions, okay? What are the primary considerations when considering a residential system? And are these the same things that the clients worry about when they call for an estimate or site evaluation?
So I think the primary consideration is going to be an economic one, right? Does this make sense for your pocketbook? And what I mean by that is, do you live in a place that has net metering? Because if it doesn't, then the economics of this project are going to be a lot different, right? These are large, expensive systems. I think the average one is about $25,000. So, I mean, these are expensive systems. They typically have a payoff of between, 6 to 10 years. So that's another consideration. How long do you want to be in your house for? I think another one is, how old is your roof? How old is your electrical system inside of your house? Because if they're rather old, you can wrap the cost of upgrading those things into the overall incentive package that is going to come in. But I really think that, like, the primary consideration are, does this work for your pocketbook, and how long are you going to be in your house? Because there are some people that, if that their family is growing, and maybe this isn't the forever home for them, and maybe it doesn't make sense to get solar. I mean, that's, or like if you've got a big move. I would say those are the primary ones.
I can guess that a big solar company is not going to have that kind of difficult conversation with a client. My guess is they're going to want to sell a solar system.
100%. Like that is my advice from me to your listeners. Like, I mean, like, your life comes first. However, if you try to have that conversation with an installer, they're going to try and sell you a system. I mean, they've got to eat.
That's their job.
Yeah.
Solar has become really big business in the United States. In my lifetime, I've gone from seeing a few demonstration modules on schools, universities, and other like institutional settings, to seeing like regular residential, commercial, and utility scale projects like you currently work on. Can you talk about this growth? What is driving this incredible increase in PV panels out there?
Well, so there's two things happening, and they're sort of dovetailing together. One is that the government of these United States has decided that they would like more solar capacity. So on the residential side, there are various tax credit programs that have been in the tax code for a while. And depending on what state you're in, there may be state incentives, for, solar capacity. And then on the other side of that, it's gotten phenomenally cheap to manufacture these things. I mean, I think the first panels in the 70s and 80s are very, very expensive. So that's where you see a lot of like dual axis trackers. If you've ever seen those, they're
Oh, they're all over Vermont,
right?
I
think, So those are a very old style system because panels were very expensive back then, and you needed to get every single kilowatt hour out of those things that you could possibly get.
We should try and briefly explain what that is. It's like a radar dish that tracks the sun, right?
Yeah. Yeah, they look like if you strap a bunch of these solar panels to like a plate, and then it sort of tracks the sun and tilts and goes through follows the sun like that. But I mean, it's gotten, as things have scaled, the price has dropped dramatically. I mean, I think panels go retail for like, I don't know, 20 to 45 cents a watt, which, I mean, back, I think as early as like 2012, things were like, panels were like $1 to $2 a watt. I mean, like the cost has fallen off a cliff. So, and that means everyone's putting them in, like utility companies are putting them in, commercial clients are putting them in, homeowners are putting them in, it's proliferating.
And I think it's barring the buying the panels and setting them up, like the maintenance costs are very low compared to like a generating facility, right? I mean,
yeah, there's really not a ton. There's really not a ton of maintenance. I mean, they're a solid state device, and a solar panel is actually a really simple thing. It just sits in the sun, and it, depending on the racking system, it can or cannot move. But I mean, you got to mow the grass to make sure that it doesn't shade the panel. You have to occasionally wash it if you're in, the desert Southwest. So, maintenance costs are pretty low, and at the end of the day, you're getting your power for free because the sun is shining.
You mentioned it earlier, but I think you'd agree that net metering is a huge deal when considering photovoltaics, right?
Oh, yeah.
Some utilities, some states even, I think it was Florida, have decided to like scale back net metering arrangements. What do you think about this, and how do we advocate for ourselves?
Well, so net metering, I think, is a huge positive for consumers. I think, I've read the arguments against net metering about how it pushes costs onto people that can't get solar panels for whatever reason. I'm not super sympathetic to those because a lot of the companies that making them are very, they're very large, well-capitalized companies.
And you can lease them oftentimes for like no money, right? If you own your home, and that's a wrinkle.
Yeah. There are some, parts about a solar lease contract that, I'm not a personal huge fan of, but I think net metering is definitely a good thing. And I think that, there are some places where the, solar has gotten overly political, and I think it's gotten way more political than really the technology needs to be. So, states like Nevada, Arizona, in particular Florida, Alabama, Mississippi, these really sunny places that could be generating a ton of power and selling it to, really making an economic case for them. Like, I think that sometimes the politics can get in the way of a really powerful technology, something that can really, benefit all of us.
And like Arizona, they got a lot of space too, right? It's
and a lot of sun, right? Yeah. What is the sun doing other than making the cactus grow and baking the top of your roof, right?
Right. Years ago, I was visiting with one of the major power tool companies. I'm sure you'd recognize the brand name. And like these companies often do, they cut their tools apart so nerdy people like myself can see inside without having to cut our own tools apart. Yeah. They were quite proud of this plastic compound they put in there to protect the wires and circuitry. They call it potting. It looks like silly putty. And they told me that they had to add this because they were getting warranty claims from PV installers who allegedly worked in the rain and when these tools would get soaked. Is that true or is that made up?
Well,
what do you think?
I think that's true because, you know, as a contractor, you know, you've got to work 12 months out of the year, right? Or like, I mean, because it's hard enough finding good PV installers. It's really hard finding those people. And then like, you've got to keep them. And so like, you have to keep them busy. And so up here in the Northeast, that means you do have to do work in winter. You do have to do work, you know, when the weather is crappy outside and you have to deal with it. For us, we try not to install, you know, really, really difficult roofs in the winter, for example, or, you know, when the snow starts flying, it's like, okay, that job is going to take an extra 2 days and we'll need, you know, a lift, you know, another lift on this. And so it's like, it's just one of those things where you got to just, you know, get some hand warmers and dress warm and, you know, and you're going for it. But yeah, like, I've never heard any installer destroying an impact driver on the job, but yeah, I mean, it's that.
I'm sure they sail to the ground all the time, right?
Yeah. Oh, yeah. 100%.
Yeah. I bet they don't survive that very often. What do you think will be the next leap in our switch to a utility grid powered by renewable energy? Can solar panels get better, for example? What about the other equipment that's part of a solar installation?
So I think solar panels are they're just gonna sort of you know, the improvements are gonna be sort of trickling in the background. I think a lot of the work that the solar panel, you know, equipment manufacturing, I think a lot of that is, you know, done at this point. I think a lot of the innovation you're going to see is in storage. And specifically, if we're talking about the residential market, I think that storage is going to become more and more present in our lives, you know, and not just standalone stuff, right? Because electric vehicles are coming on the scene and they're, you know, taking up more and more market share. And there's a big push to make them more marketable, to get them into more people's hands. The really fun and crazy part about that is now you have this battery that sits in a garage that you hook up to your electrical panel, and now you can start doing all sorts of things, right? I mean, because your car sits, what is this? I think it's like 95% of its useful life is, you know,
just sitting
around, right? And now if you've got, you know, a battery that's plugged into your house, okay, maybe I can use the energy in that battery to, you know, let's say power my dishwasher, or, you know, to avoid some peak loads, or maybe, you know, maybe the grid goes down and, you know, and I can emergency power my house for, you know,
days,
an hour,
hours or days.
Yeah, an hour, 2 hours. And then, you know, on the flip side of that, disaster response, right? So you have a hurricane that comes through and just blows down a bunch of utility lines. The grid is out. You drive in, you know, a fleet of 100, you know, electric pickup trucks, and you start powering people's devices, or, you know, you can, you know, turn on somebody's house for 45 minutes, you know, just to, you know, do stuff there. So I think the big story in the next 10 years is going to be batteries. It will be. They are going to get a lot cheaper, and they're going to become a lot more present in everybody's life.
This is a related question, and you answered it to some degree, but do you have any thoughts on how we'll solve the intermittent nature of renewable energy and how to store it so we can use it when it's not going on, right? When it's not happening?
So yeah, there's if we're talking about sort of like a larger sort of grid scale problem, energy storage is going to be how we solve that, ultimately. What form that takes, it could be a lot of different things. So there's a lot of different energy storage methods, and not just, chemical batteries.
Yeah.
There's ways to store energy in heat and, hot, cold. So using like really large heat pumps to store hot and cold liquids. You can pump air. You can, there's some really wacky.
There's a demonstration project in northwestern Pennsylvania that uses a reservoir to pump water. Yeah, pumped hydro.
So there's an even crazier project that I've heard of, and I think they're going to go there. It's a company that's about to go public, but it's in potential energy. So it's, picking up large pieces of granite or concrete or whatever, and then stacking them and then unstacking them. Whether that specific idea works out, I'm not so sure, but like,
I mean, it's a pendulum. It's an old mechanized clock, right? Is what you're doing in essence.
This thing is it's like, 6 cranes, sort of. It looks very, very strange, but I mean, so like right now there's a lot of this wild experimentation. People don't know what the next big breakthrough is going to be, and so they're just throwing everything at the wall. But yeah, ultimately, working on the storage part of it is going to be how we power things when the sun doesn't shine and the wind doesn't blow.
It seems like it's a solvable problem to me.
Yeah, it seems very doable. And like you think of some of the other really large challenges that the construction industry, or like, maybe society in general, like going to the moon seems really, really hard, but it happened. And it happened, 60 years ago. So it seems like, these are challenges that can be accomplished. They can be overcome.
So this brings me to my favorite question of the show, George. What is your own house like? And you're in Buffalo still, right?
Yes, sir.
And do you live in a new house, an old house?
So I live in a 1946 single-story cape. And so I bought this house in this past May, and it has...
Is this your first home, I can presume?
Yes, this is my...
Congratulations.
This is my first, well, thank you so much. It's been overwhelming, the amount of the amount of things that I came into this place thinking were gonna be how I do things, and it just fell apart. So I have a chimney that's, basically falling apart, which I want to take the house fully electric. That's in the plan. And I also...
Can I assume you have a gas furnace now?
Yeah. Yep, I have a gas furnace from the 90s. I have, a gas hot water tank that vent through the chimney. I eventually, wanted to take it fully electric, rip the chimney out because it's a massive thermal bridge. And it'll also allow me to, patch that nagging roof leak that I've got.
Yeah.
But yeah,
roof is no place for a chimney. That's what I'll say.
Yeah, exactly. So, this house is, I mean, there's definitely a lot of work to be done. I have a lot of painting that I need to do. The whole electrical system is
a date to the
really
beginning.
Old.
Yeah.
No, it's so actually someone did an upgrade. I want to say at about the early 2000s.
Yeah.
And so like I have a more modern panel. I have a sub pump, but it's I work in solar, for God's sakes. I want to rip it all out and get, the new shiny, and then, put a metal roof on, and then get, a giant solar system. You're like, yeah, of course I want to do that.
Yeah, it's only time and money, right?
Yeah. And actually, Patrick, I will say this. So I was thinking initially, like, okay, maybe I want to do some like exterior roof insulation, maybe that's what I want to do. And then the members of a certain podcast, basically said that was a dumb and terrible idea. Just put an air conditioner upstairs, and then that'll solve your problems.
We've been hearing about these, I guess, gold medallion houses, which were like all electric in the 60s, and they had these radiant panel ceilings, all resistance, and oh my God,
that's a lot of power. That is a lot of juice.
This guy told me that the previous owners of the house would have $600 monthly electric bills in the wintertime.
Wow, yeah.
I think that's, maybe you agree with me, but I think that's some of the pushback we get from people when we say we're going to have an electric house, right? This is what they're imagining is electric resistance and uncomfortable, and like it doesn't have to be that way, right?
Yeah. It absolutely doesn't have to be. And I think that there's a lot more understanding that's being pushed into the building world, right? Because so many things are changing, and we have to get smarter about our homes and houses, right? Because we can't build really leaky homes anymore and just throw in a larger boiler and call it good. No, we have a problem with carbon dioxide, and we need to deal with it in order to combat climate change. And so it's going to take, a legion of really good trained professionals to come into these homes and figure out how they're going to improve things, because ultimately we have to go fully electric. We have to, we can't keep coal and natural gas and fuel oil. We just can't use these things in a residential system. We have to go electric. And so it's going to take a lot of people to figure it out, how we do that.
And I think you'd agree your own situation would confirm that is, it's not easy or inexpensive, right? It's going to take a national commitment, I would say. Yeah.
And I mean, it shouldn't be on the homeowners, right, to figure out how to do this. There should be people that make it easy. And yes, those people should, be able to turn a profit and be able to ply their trade. But I don't think we're going to educate, the 160 million homeowners to start caring about air sealing and insulation. I mean, I just don't think it's going to happen.
Well, that would make my show really big, George. I think you'd agree.
That's right. The Fine Homebuilding copies would just be flying off the shelves in that future.
It has been such a pleasure talking to you, George.
Oh, Patrick, it's been an absolute hoot and a half.
What do you want to ask or tell our listeners before we part company?
Well, I just want to, encourage, the people that are, maybe considering a career in renewables to, really seriously consider it, because, there's just massive amounts of opportunity to join this career. It's very fulfilling. I wake up every day thinking that, like, the stuff that I'm putting in, the projects that I'm building are really a benefit to us all. And so if you're curious about the renewables industry, we need you. And, for the people that are working with, young professionals like myself that have to deal with people screwing things up, I just encourage you to, be empathetic and be patient, and, let's, teach
let them try, right?
Yeah. And let's build the next generation of working professionals. And let's make them really, really good, because we're going to need them.
Amen. Well, unfortunately, that is all the time we have for today. Thanks to George Hart for joining us, and thanks to all of you for listening. Please remember to send us your comments, questions, and suggestions to fhbpodcast@taunton.com. And please like, comment, or review us however you're listening. It helps other folks find our podcast. Stay safe, everybody. Keep craft alive. Happy building.